Hello guys, Dr. Colbreth here with an example from chapter 16, problem 9. It says a 2-meter long string is fixed at both ends and tightened until the wave speed is 40 meters per second. What is the frequency of the standing wave shown in the figure? So here we have a representation of the standing wave, and this representation shows both the upstate and the downstate, so the wave alternates between the state in the standing wave formation. And in order to have a standing wave on a string with fixed endpoints, we have to have a node at each end. And so in this case, we have a fixed endpoint, and so we have a node of the standing wave at each end, and we have 1, 2, 3, 4, 5, 6 antinodes visible here on the string. So what we need to do is figure out what the frequency is for this wave. For that, we're going to use the fundamental relationship for sinusoidal waves, which is that the velocity is equal to the wavelength times the frequency. And we want to get the frequency. And in order to get the frequency, we just do a little algebra here. Get that the frequency is going to be equal to the velocity divided by the wavelength. And the velocity is given in the problem 40 meters per second. But what is the wavelength? Well, we know that this distance, the length of the string, is given to be 2 meters. And on this particular wave, we have 6 antinodes, as I mentioned already. And a full wave is this distance here, right? 2 antinodes makes a full sine wave. And so if we have 6 antinodes, we have 3 full waves on our string. And so each wavelength then is 1/3 the length of the string. So lambda is going to be equal to 2 meters divided by 3, or 2/3 of a meter for each wavelength lambda. So we can plug that into our expression for the frequency. We get that the frequency is equal to the velocity, which is given to be 40 meters per second, divided by the wavelength, which is 2/3 of a meter. And so we can then get an expression for the frequency, which is going to be equal to 3 times 40 is 120 divided by 2, which is 60 hertz, or 60 per second. So we can double check that our units check out. The meters cancel, and we have seconds on the bottom, so a per second or an inverse second is in fact a hertz. So the frequency is equal to 60 hertz.